Let us move on to the next concept that is called as velocity selector. Very nice concept. Yes, velocity selector. In physics, what is our in physics? If you just look at the name of that concept, you can directly somewhat you can get an idea about that concept, because the name is itself the face of that concept. Here it is a velocity selector. That means it will select the velocity. Velocity of what? Whether the velocity of charges, what sense it is telling? I mean, which velocity of what particle it is selecting? That is what we have to understand. Before that, I want to give an example of some general examples, which you will see in your surrounding. Whenever there is a fracture in a bone or in some other part of the body, or some other issues are there, then the doctor will suggest you to scan your whole body. There are different techniques are there. There is X-ray scan is there, MRI scan is there, different scanning which sound Doppler effect is also used for scanning. Different techniques are. So among which I am talking about a MRI scanner. So in MRI scanner, that will have some reductive material, and after activating that reductive material, that will emit some radiations, and it will penetrate or pierce through our body, and we will get some pictures of our body, so that we can see some damages, or it will help the doctors to cure the patient. So where in that MRI scanners, they have to produce some radioactive they have to produce some rays that are actually produced by radioactive elements. If they wanted to produce that radiations, they need to incident some high energy, very high energy particle to that radioactive material, radioactive substance. Otherwise, it will not emit radiations. So, creating the particle which are very high energy is very difficult. It is not possible. That is why we have to use some devices. Actually, that is called as a cyclotron. Simply, it will be called as a particle accelerators. Particle accelerator means that is a chamber, that is a device which will accelerate the charged particle, which will energize that charged particle. So that if that charged particle is incident on any radioactive material, it will emit the radiations. So if it is able to vary the velocity of that charged particle as our design, then it will be very helpful for the society. So then how it works, let's see. There is a concept of velocity selector. Yes. Then how to select that velocity of any charged particle as our requirement. So to do so, what we have to do is we have to take two fields. That is called as two crossed fields. So here let me take, this is the direction of magnetic field. This is the direction of electric field. There is a charge which is moving along this direction x, along x with the velocity v. If this is so, here is angle will be formed between the v and v. So the direction of force acting on this charged particle moving along x direction will be opposite, means it will be downwards. That is a force due to magnetic field. So that is moving perpendicularly it is moving force due to magnetic field, which is directing downwards. And there is another electric field that is also acting upon that charged particle. So the particle we have considered is a positive charge, and here it is an electric field. Then the force acting on that charged particle will be along this direction. This is the force due to electric field. These are the two electric fields, force due to electric fields in opposite directions. Along that direction, the particle with the velocity v, it is moving. If this is the situation, then how can we select our required velocity of a charged particle? Yes, let's see. Then, if the two fields exist, then we should. Then, if you wanted to find the force on the charged particle, then we should take Lorentz equations. Then, Lorentz force is given by F is equal to E into Q plus Q into V cross D. Here, let me write unit vectors. I cap is on the x direction. So y axis, let me write this z axis. Unit vector along this is a j cap. Along this is a k cap. These are the desired unit vectors along different axes. So let me write from figure vector E. How to write the vector E? Vector E is along the y-axis. It can be written as E into j cap. So here E means it is a magnitude, J means its unit vector. Means this indicates the direction, this indicates a magnitude. That is why it is a vector quantity. It has both magnitude and direction. We split the magnitude and magnitude and direction. It can be written like this. So what we want here? V. V can be written as V. V is along this direction. V is equal to V into I cap. And V can be written as vector V along this direction. It can be written as V into K cap. Let's substitute here. So F is equal to E into Q, E into J, E into J, E into J into Q, plus Q into V is equal to V I cap. You can take it outside, but there is nothing what calculation you can do here. V into I cap. B means it is a V into K cap. So what you have to do here is, these are the two vectors. You have to multiply these two vectors. So QE, here it is a J cap plus Q into, these are the constants value here. Q into VD. I cap cross K cap. I cap cross K cap means I cap cross K cap. That is minus J cap. That we have discussed. We have discussed about it in the first year. So it will be minus J cap. So here further you can write this as vector F is equal to J cap Take the J cap as outside here because J is common here. QE plus, you can also take the Q also here. Let me take Q here. E plus BB J cap. J cap. Now we have the equation for force F is equal to Q into E plus VB J cap. Now F means it is a total force which is acting upon this charged particle which is moving with the velocity v. So it is moving under the two fields. One is magnetic field, another one is electric field. So if it is able for us to make the magnetic field is equal to the force due to electric field by varying this electric and magnetic fields. That means by varying magnetic field and electric field, we can make the force due to magnetic field is equal to force due to electric field. If it is possible, if we are able to do so, we can do that. If you do like that, then what will happen is these two forces are equal. What I said is using the value of electric field and magnetic field, we equated the value of force due to magnetic field and the force due to electric field. If the two values are equal and they are in opposite directions, then what will be the total force acting on this charged particle? It will be equal to 0. So that I am directly writing as if force due to electric field is equal to force due to magnetic field, then total force F is 0. F will be equal to 0. So that I can write F is equal to this F is equal to 0. I have removed the vector. So Q into, I am multiplying, open the bracket, J is cancelled because F is equal to 0. I am not writing that J, QE plus Q into B. Now, sorry, here actually I should write negative because of the sign of J. So this is minus. Now take the QEB or minus E here. I take the minus QEB here and it will be positive. So that is QE equal to QEB. So QQ cancels here. So E is equal to, I will rearrange like this. QEB is equal to QE. I hope you understood. And QQ cancels. V is equal to E by B. So this is an equation for velocity. So we can select the velocity of this charged particle by varying the electric field and magnetic field. If the charged particle is moving with this velocity under the electric and magnetic field, then it is undeflected, not deflected by any kinds of forces, because total force acting upon that charged particle will be 0. So you can vary the velocity of charged particle of your requirement. That means a desired value of velocity you can get by varying the values of this electric field and the magnetic field. So this is the help of this is a use of this concept called velocity selector.